Hello class, this is your instructor, Miss Birchfield, and this lesson is on factoring GCF method. And the key with this is to know what does it mean when we say to factor. Well, factor means that we're going to undo a polynomial. So if you think about the previous sections when we were multiplying polynomials, we were doing like a monomial times a binomial. We did binomials times binomials, and we got the product or the answer. What we're going to do is now take binomial or a trinomial or four terms, and we're going to break them down into parentheses, which is multiplication. In this method, we're going to use greatest common factor. So what we'll do for greatest common factor is we'll look at all of the terms, we'll look at the coefficients of the terms, we'll look at the variables of the terms, and determine what they all have in common. What is the greatest thing or greatest number or variable that they have in common? And this is always the first step when you're factoring. So whether it might have a GCF, it might not, but you're always going to want to check this first. So to factor a GCF, we will look at all of the terms, we will identify what's common, and then of course we'll look at the coefficients first, and then we look at the variables. When we determine the GCF, we write it in front of this parentheses, and then once we do this, we will complete the inside by dividing by the GCF. So these first two examples, all we're doing is just practicing finding the GCF from the list. So the first thing we'll do is we'll look at the coefficients. We've got 14 and 35. Always look at the smaller of the coefficients to determine the factors. Well, 14, the factors are 2 and 7, 1 and 14. Now, once we determine this, we're going to think about those numbers. Will any of these be factors for 35? Well, the only one that I know I can see is 7 is going to be what's common. So we're going to write 7 as part of our GCF. Now we're going to look at these x's. There's 3 in the first term. There's 4 in the second term. So at most, both of them have 3 in common. So to help you with that, when you're thinking of your variables, always, if they have a variable in common, always pick out the smaller of the exponents. So this is our answer. That's just the GCF from the list. Here in the second one, we're going to look at 12, 4, and 60. So my smaller one is 4. So factors of 4 are 4, 2, and 1. And I'm not really concerned about the number 1. So I'm going to think about the larger of these factors, this 4. Is 4 a factor of 12? Yes, because 4 times 3 gives us 12. Is 4 a factor of 60? Yes, because 4 times 15 is 60. So we're going to write 4 as part of our GCF. Now let's look at these x's. We have 2 in the first term, we have 3 in the second term, and we have 3 in the third term. So they all have x's. What's the smaller? 2 is the smaller exponent. So that means this term we're going to have an x squared as part of our factor. Now we'll look at y's. We've got a y in the first term, we've got a y squared in the second term, and we've got a y in the third term. So we have y's in all terms. The smaller exponent is going to be 1, so we're just going to remove 1y as our GCF. So this is the GCF from the group or from the list. Now we're actually going to factor. So when it says factor, keep in mind that we're going to have parentheses. And what we're going to do is we're going to determine the GCF. So we're going to look at 4 and 16. 4 is the smaller of the two. So let's think about factors of 4. The largest factor is 4. Does 4 work for this 16? It does, because 4 times 4 is 16. So we're going to write a 4. Now this term we have a y squared. Does the second term have a y? It does. It's got 3 of them. So we're going to take out the smaller of the two. So we're going to take out y squared. Now when I look at this second term, I see there's an x. Does this first term have an x? It does not. So that means we will not have an x in this GCF right here. So what we're ready to do is we're ready to write our parentheses. And then what I'm going to do is going to erase this here, and I'm going to visually show you how to determine what's going to go in these parentheses. So we're going to write our GCF here underneath these terms. And then I'm going to divide each term. So 4y squared divided by 4y squared, anything divided by itself is always 1. I'm going to bring my sign down. 16 divided by 4 is 4. And remember, so I've got an x in the numerator. I can't combine it with anything in the denominator. And then I've got y cubed divided by y squared. Remember, you subtract your exponent, so that's just going to give us y to the first power. And always remember that the x and the y, those are understood to have a 1 as an exponent. And to check this, we could always distribute the 4y squared back out to what's here in the parentheses, and it should match what we started with here. Now we're going to look at 39 and 26. The smaller of the two is 26. 26, 13 times 2, 26 times 1. The largest number is 26, but I know it's not going to work for 39, so the second largest is 13. Does 13 work for 39? It does. So I'm going to write 13 as a GCF. And then I'm going to look at these variables. There's 3 x's in the first term. There's 2 in the second term. So we can take out 2 from both. And then we've got a y cubed and a y cubed. Since they're both the same exponent, we can take out a y cubed. So I'm going to start my parentheses. I'm going to come up here, I'm going to erase these, and then I'm going to write my GCF underneath each term. And then we're going to divide each term, or simplify each term. 39 divided by 13 is 3. X cubed divided by x squared, we subtract, that just gives us x to the first, and the y's go away. Bring our sign down. 26 divided by 13 is 2. The x's will go away, the y's will go away. And why do they go away? Well, remember, think about the rule. Subtract 2 minus 2 is 0. 3 minus 3 is 0. Remember your rule, 0 exponent is always going to be 1. I can close the parentheses, and I'm done. I have my factors. These last two examples, we're going to do the same thing. So we're going to look at our coefficients. We have a 6, an 8, and a 2. So I'm going to look at the smaller 2. The only factors are 2 and 1. Remember, 1 we're not going to be concerned with. So let's see. Well, 2, is 2 a factor of 8? It is. What about 6? Yes. So we're going to write 2 as a factor. Well, they all have x's. So there's 5, 4, and 3. The smaller is 3. So we're going to use the smaller exponent in our GCF. Now what we can do is divide our GCF by 2x, divide the terms by our GCF, 2x cubed. And you really don't have to show it like I'm doing if you feel like you can look at it and determine. But sometimes, students are visual. 6 divided by 2 is 3. x5 divided by x cubed is x squared. All right, negative 8 divided by 2 is a negative 4. x4 divided by x3 is x. And then 2 divided by 2 is a positive 1. X cubed divided by x cubed, that's going to give us a 0 exponent. So this is just going to become a 1 on that last term. And again, if you're unsure, you could always distribute this back out and see if you come up with that. In this last example, we're going to look at 12 and 3. 3 is your smaller number. 3 is a factor of 12, so 3 is a GCF. They both have x's, so we're going to take the smaller of the exponent. And then you can, like I said, you don't have to do this, but if it helps, we can come over here and write our GCF underneath each term. 12 divided by 3 is 4. x4 divided by x squared is x squared. And then this term, since they're both the same, is just going to become a positive 1, because remember, anything divided by itself is 1. Thank you for listening. If you have any questions, just reach out to me, send me an email, and I hope I can help. Thank you.